All right.
All right, we're live on Facebook, Eric.
Hey, everybody.
Welcome back. Eric
Awesome.
just had to do a quick wardrobe change.
We had a great time at Barber, didn't we? With Jay Zilla.
Yeah, we did. A lot of people probably saw our picture on Facebook. Tell us a little bit about what happened. Eric was down here at Barber Motorsports Park Monday, Jay Zilla track days.
Yeah, we were asked to come down and introduce data to those that were interested. This is a typical first approach for a cultural change in an organization that wants to learn data. It's what you do, man. You Andrew, you go there and you help turn people onto data. And we had two of us doing that to a whole bunch of folks having a great time.
Yeah, that's the goal. And notice we had Johnny Chachowski watching. Johnny was there on Monday as well. Johnny's with 9 Lives Racing. If you need a wing or a wang, he's the guy to talk to.
I'm so anxious to talk to him. We talked about Corvettes and balanced Corvettes and Miatas. I'm hoping he comes to my NASA Great Lakes region and talks about Aero, to be honest with you.
I think that'd be a great resource. I think we can make it happen. Before we get into our content here, our subject, I just wanted to drop a quick link to the notfamousracingdriver.com. Eric, I'm not sure. Actually, you know Davin Sturdivant.
Absolutely.
Davin is awesome. He works with Chris Rode on Studio Road. They're an automotive marketing consultancy and agency. They do marketing consultant for automotive companies, and they started a brand called Not Famous Racing Driver. And if you use the code APEX Pro, capital A, capital P, during checkout, you can get swag from them, the Not Famous swag, 10% off.
What's
so
the
check
website,
it out.
Dude? What's the website? Where do we go?
Website is, I just posted a link in the comments, swag.studioroad.com or notfamousracingdriver.com. We got Marlon on here as well.
Marlena.
Yeah, Johnny says he's welding up wings with the broadcast up right now. Cool. Scott Spears on board.
BMW
Awesome.
M4. BMW M4. Actually, I'd like to come down, Johnny, and do that with you. That'd be a whole neat vlog and everything, having a good time.
He's right near Road Atlanta, so maybe we can figure out a way. And I know he has a lot
doing
of
Monday afternoon. Anyway.
Right on. All right, so we're going to talk a little bit about gear selection and how do we decide what gear we need to use for a certain corner, or why it's important to look at that. Let's talk about going to a new track at Barber. A lot of folks with Jay Zilla actually hadn't been to Barber, so that was something that we talked about with several folks. Where are you shifting? What gear are you using? Eric, enlighten us a little bit. What do you see with most drivers that you work with? What are their habits with regard to shifting?
I would say you're a prospect to have track time opportunity reduction. If you're self-taught and you either have a big V8 and you like to hear the engine, to be quite frank with you, and you don't have other people around you to compare to, so basically you're shifting too much and that loses time. And the same thing if you got a custom car with a high revving 4-cylinder, you like to hear that thing and you overuse it. So those are candidates. They're early candidates. You need to go through that phase to understand which gear selection is faster for time reduction.
That's a great way to put it. If you like hearing the sound of your engine and you're going up and down through the gears, then you're a candidate for opportunity.
Dude, I'm an instructor, and I'm like, why are you doing that? And they're like, oh, I love the sound of my motor. They'll tell you. And they usually talk about, buying mufflers because of the sound. These are self-taught DE drivers typically that have a lot of lap times. And I don't want to say incorrect lap times, but they sort of bypassed quality instruction. And I don't say that rudely, but that's how it gets. You need somebody with you to say, hey man, why are you doing that? And then you need a way to either try and measure it, or you take their word for it, or you learn data and you prove it. And it's part of your DE test effort. A lot of time trial guys will do that. But the opportunity is in a lower, the big opportunity is in a lower DE experienced driver, because that's where it's more gross. And that's where they need
Yeah.
it most.
Do you find most people shift too frequently or too infrequently?
Dude, that's a loaded question. Yeah, too many people shift too much. Period.
People shift too much?
Oh yeah.
Absolutely. Cool. Well, we're going to show how you can use the APEX Pro OBDII interface. As of yesterday, an app update came out, and there's actually software in the app now that deciphers what gear you're using, and it's using a really simple formula, and you can actually adjust it to make sure that you're using the correct gear, or you make sure that the software understands what gear you're in. And I'm going to show you guys how to do that with the app. But I'll echo what Eric said. I think it's extremely common for drivers to want to shift too much at the lower level, especially think about, yourself. If you've been driving for a while, we got a lot of experienced drivers on here. When you first got into HPDE, what do you want to do? Why do we really want to go to the track? A lot of times it's just so we can leave our foot wide open on the throttle as long as possible, right? And that means going up through the gears, fast and furious style, ripping up second, third, fourth, fifth. Brian has a question. Brian LaRose, he says, Andrew, can you ask Eric about short shifting to save fuel when endurance racing? That's an interesting question. So that's something that we can definitely discuss a little bit without any specific data on the specific, car. It's going to be hard to tell you exactly what that looks like, but that's definitely a valid reason to be using more gears. But again, we're assuming that that's a more trained driver that knows the appropriate gearing for the track. We're more talking about, should I use third gear here or fourth gear here is probably the most common one, right, Eric?
Absolutely. And back to that question, the answer is yes on short shift. That saves the car, it saves the motor, it saves the heat, is less heat in the motor. And it's typically always reflected in MPG. You just got to measure it to prove it. Just go out and at your next lap day, right? Or whatever you're doing, you go out and turn a bunch of laps, and that's on your test list, right? It's on your test list of, I'm going to do this. Just like,
yeah, absolutely.
Just like what we're going to talk about, which is trying different gears. That's what you do. You go test, you go practice. All you only need is a couple laps to do it. And it's a couple corners, if you think about it, and you just try it and you got something to measure. Let's show them how to do that. Show them how to use your new feature, bro.
Yeah. I'm going to share the iPad app screen over. This is APEX Pro app version 7.4.2, and it came out yesterday. So if you haven't updated your app or you haven't checked to see if the app has been updated, I would hop in there now. We're looking at the APEX Pro screen, the app screen now, and you'll notice if you have the OBDII module attached, you'll actually see data when we're looking at this screen, but you'll notice this even if you don't have the OBDII monitor. Right here, our channel selection option. I'm going to pull up some annotations on the screen real quick so we can make this stuff pretty vivid and obvious here. This is our channel selector right in the middle of the page. I've got all my different channel options, and that's going to control what I see overlaid on the track. It's going to change the coloring to reflect the channel. Now, this driver right here has the APEX Pro OBDII interface plugged into the car. This is a C5 Corvette. Shout out to Doug Francis if he's watching. This is Doug's data. Thanks for letting me use your data, Doug.
What up, Doug?
Good dude, quick driver. National Corvette Museum. This is a C6 Corvette. I'm sorry, C6 Z06. And what we're looking at right now is throttle position, and that's how we know that the OBDII monitor is installed. We've talked a lot about how to plug in the OBDII, how to connect to it on here. The latest app updates make it even easier and more reliable.
How many minutes for a typical install on something like that?
3 to 5 minutes max.
And can you be up and running, driving around? This is a loaded question, right? Drive around the neighborhood and you can look at your data and figure it out, confirm it.
Yeah, absolutely. Create a custom track in your neighborhood and you can look at all this.
Okay.
And this
let's do a video on that in the future.
Yeah, absolutely. So the big difference between the APEX Pro OBDII module and others is that most OBDII modules out there or readers, especially ones that work with iOS devices, will not log data in a sensical format. So if you buy a $50 one off of Amazon, it's just going to give you a CSV file. There's some other options, some other data products that have OBDII devices, but they're a little more expensive. The APEX Pro OBDII is $129. And it's going to give you all the OBDII's data here. So the very bottom channel now, and you can follow along if you have your app with you, make sure it's updated 7.4.2 and scroll all the way down to gear right here. right here in the middle. So what we're going to see now represented over the track map is a different color for each gear. Just like with any other data channel, you can tap on the color to see a number associated with it. And in this case, 3.0 is going to represent third gear. 4.0 is going to represent fourth gear.
Hey, brother, can you drill down on one of those changes? I'd love to see that up close. Anything.
Sure.
What's that
like
look
this?
like? Yeah, yeah.
And the point that I'm going to make here is this is actually if anyone knows turn 10 at NCM, they know that this is probably a second gear corner in most cars. Would you say that, Eric?
Yep. Yeah. Big V8s can pull out of there.
Yep.
Sometimes people can throw third. It's something you got to test, right?
So
you got to compare. You got to compare.
Exactly. And this is just the data logged. I haven't modified it at all. This is just the data that I got. After this driver logged the data, this is what he saw. I'm going to show you guys how we can use this feature to actually make sure that it's showing us the right thing, because this is just using software to use the RPM, and it's looking at basically, I'll show you in just a second, speed and RPM, where the correlations are, and it's defining the gearing, but it might not necessarily do it right the first time. So you can adjust it to make sure it's right.
If you're not a brainiac, which I'm hoping many people are not, because this whole educational series is designed for that. You're basically making a mathematical computation, and it says, well, if the RPM is this and we're going this many miles an hour, then we must be in this gear.
Yes.
And it's an industry standard, by the way, of how that's calculated. Don't be afraid of it. You do it one time, it's easy. We can help you do that too.
Yeah. And I'll show you guys what that means right now. So what I'm looking at right now is the incorrect gearing displayed over the track. This driver is going to be in fourth gear right here where it says 5. This is actually fourth gear in this car. And this is actually third. And so what I would do to determine when you log your data with OBD2 interface, go to a corner where you know conclusively I'm in this gear. At NCM, turn 10 is a great one because in most cars it's going to be second gear.
You just need one corner confirmation. Correct?
One corner confirmation, one place where you know unequivocally what gear you're in, and then you go from there. So for this driver's data in particular, he could probably tell me if I asked him, hey, what gear are you in going into turn 5 right here, this big fast sweeper? And he'd say fourth gear. And I'd look at it and I go, fifth gear. All right, let's fix something. Let's change it. So if you're looking at this right now, what we're going to look for, and I'm going to annotate on the screen again. See this gear right there, Eric?
Yes, sir.
Cool. We're going to tap that.
So you used it this past weekend at Barber with Jay Zilla a few times. Yep.
Yeah, on Monday. That's right. And this has actually been changed. Now it's viewable on this screen. Before we had to actually, it was done a little differently. But make sure you have gear selected down here, and that's going to make this little gear appear. Tap the gear, and you're going to get this page.
Don't scare people with this. Right?
Too scary?
This might be overwhelming for some new folks. What'd you just do, dude? What'd you just do?
So we're looking at these two guys right here. We've got gear ratio versus RPM, and speed versus RPM. So we've got two graphs. All right.
So what's the axis on the one you just clicked?
So this is RPM on the X axis, 6,000 RPM, 1,000 RPM. And this is speed.
Okay. Both of those being the speed being logged by the APEX Pro without the OBD2 module and the RPM, correct?
Yes.
And
correct.
the RPM gives us that data through standard.
Yes.
Everybody get that pretty much when you plug in the device?
When you plug in the OBD2?
Yep. Will people get RPM?
Everybody will get RPM. Yep. Everybody will get RPM. So this is available to anyone using the APEX Pro OBD2 interface. Anyone that's got an OBD2 device or OBD2 port in their car. So 96 and newer, this will work. 08 and newer is better as far as number of data points per second. But
so that yellow, if you take the cursor somewhere at 4,000 RPM, right? The yellow line, yep. That is a mile per hour range, if you would.
Yes.
Look like 5 mile an hour, something, 5 or 7, something like that. Oh, give or take. What's vertical there?
Somewhere in here, the yellow range is going to go from about 50 miles per hour to somewhere in this range, right?
Cool.
Okay. So the main thing that we want to look at here to correct our gearing. So right now we're seeing a gear too high, right? It's telling us we're in fifth gear when we're actually in fourth gear. So we have these selectors down here, and I'll liken this to something that some on here might be familiar with, especially if you're my generation. If you're a millennial or a old or a younger Gen X, you'll understand this. You've seen this before in Forza Motorsports. You've seen this before in Gran Turismo, where if you have a vehicle with an adjustable gear ratio, so a sequential transmission, or a vehicle with an adjustable final drive ratio, you see something that looks just like this, and you can adjust the ratios of the gear. So all I'm doing here is I'm adjusting my gear ratios to fit the data. So we see these plots. See how all these plots are the same color right here?
Mm-hmm.
These lines with the dots that go through the data diagonally represent the gear. So first gear, second gear, third gear, right? And so on. So the problem that we're having here is I've got two gears right here, when in reality, I'm willing to bet this is all first gear. Does that make sense, Eric?
Absolutely. And I'm looking at that yellow one. There's no dotted line in between there, no calculation.
Exactly.
Right there. Yeah.
Exactly. So let's look at, where do you top out in first gear in most cars? 25 miles an hour, 30 miles an hour?
Oh, golly.
Right.
Everybody's trying to pull second coming out of pit lane and throw it sideways, being all hot doggy, right?
So here's 30 miles per hour. So, this is not second gear right here. This is telling us right now, this second dotted line up is saying that second gear ends at, about 40 miles an hour.
Say that again. Show everybody that again, please.
I'm going to use a different annotation tool here. This would be, if this is correct, the line that I'm drawing right here, that'd be the top of second gear, between 30 and 60 miles per hour.
Cool.
Right here. So that's obviously incorrect. So what I'm going to do now is go down here, and this is fun to play around with. I promise it's not hard to figure out. I'm going to point at this dot right here. And what I'm going to do is move this first gear up to match where the actual top of first gear is. So it's right here.
Was it bringing second with it when you slid that?
It's going to move second up above it.
Oh, cool.
Because it knows second has to be higher.
Sure.
So then second gear is actually going to be these orange dots right here. See how it's sliding third gear up now?
Absolutely. Yep.
So third gear is actually this next fit of data, these next points right here. That's third gear. All right. And fourth gear, which is going to be our top gear on this track in this car, is this last set of data right here. So the top of fourth gear is, let's see, 1, 2, 3. This is our fourth gear line, right here.
Is this driver pulling fifth gear in that green right there at 3,000 RPM? Is that what that means right there?
That's fifth gear right there.
So he's probably
they're not using that. They're only using that on their cool down lap. I'm willing to bet.
Sure. Yeah. Makes sense. Lower RPM, a little bit of time there.
Exactly. So what we're really looking at here is our top speed is about 140 miles per hour for this car on the track. That's the top of this data line right here. That's fourth gear.
We'd be able to speed trace, right?
Yep.
He's going to touch 140 a couple places.
Yep. We'd be able to see that top speed on the speed trace. So what was important before we got to this screen was to look at where that confirmation of gearing, right? In turn 10, we know that we're actually in second gear. The data was telling us we were in third. So I went in to adjust this. So I know all the data now was a gear too low. Now I've adjusted it. So when I hit save down here, it should go back to everything being correct. If I go back to default, that'll go back to what the data set it to. So I'm going to tap save. And then it's going to take a second for it to save up here. So what I do is go down to your channel selector, slide it all the way up. Whoops, slide it up to Apex score. Give it a second. Slide it all the way back down to gear. All right. Does this look right to you, Eric? Fourth gear right here.
Yeah, is the indicator's confirming.
Yep. So that means the yellow is going to be third gear.
Well, let's find out, right? Yep.
And the red's going to be second gear.
Which the driver confirmed that's where he was going. And you and I both know, and everybody knows, that's the slowest corner and the only second gear corner.
That's right. So what's your synopsis on, is this driver, in your opinion, Eric, based on what we're seeing? Every color is a different gear now. So red is second gear, yellow is third gear, fourth is green. Green is fourth gear. What do you think about this driver shifting? Is he shifting too often, or
Oh,
is it pretty appropriate?
well, I am looking just above your cursor right there where it says 2.0 second gear. And I'm going right above that to the yellow, right, where it's 2.0 second gear value. And
Yep.
I know in a big old Corvette in the dry, that thing is running out of RPM, right about there in the yellow.
Yep. Right
So,
here.
yep.
Well, you want to see how much RPM he's turning? Because we can
Sure.
do that. I'm going to go up to the RPM channel. 4230.
Interesting.
Well, that's after he's decelerating. So let's first go to longitudinal G.
Yeah.
And let's set our cursor. Okay, so now we know where the driver's braking.
There you go. He's hustling. That's a fair amount of braking. That's a big old handful of braking. 1.2
Get around
value.
the track
Yeah.
pretty good.
Yeah.
You know Patrick Darty, right? That we met at NCM.
Yes. Yes. Another Corvette guy. Hot shot. Really fast.
Doug is Patrick Darty in 40 years.
Wow. Awesome, Doug. Love to meet you.
Good dude. So what I'm going to do here is I'm going to look at long G. The red right here is where this driver's going to the brakes. So I'm going to go where he's still accelerating positively. What we're looking for here is his max RPM before the braking zone.
Time out for a second. Look at that value, everybody. That value of that 0.2 accelerating, well into some good speed. That car's pulling, and he's hoofing through there, and it's still pulling. Fair statement?
Yes.
Tell him the importance of what that 0.2 means. The value of that. Electric car, right? A 3-cylinder, 100-mile-an-hour top speed car versus a beast.
Yeah, that's an important distinction to make. So as speed increases, your forward acceleration is going to start to decrease, right? Because of wind resistance and gear ratios and stuff like that. In a Corvette at this speed, which let's see how fast we're going. 100 miles an hour with 500 horsepower roughly in a Z06 Corvette, it's still pulling pretty hard. 0.2 positive G plus.
It got there real fast out of the previous corners.
Yep, that's right. So to Eric's point, if we're looking at this same data in a Miata, in a 94 Miata, right, it's probably going to be less G represented there. So we're going to be looking for
less than 1?
Potentially, probably between 0.6 to 1.2, 1.3, somewhere in there.
That's how you know in the straightaway about what kind of data of a car you're looking at if you don't know the car. How hard's it pulling?
Yep. Absolutely. Very important.
And how hard it's pulling off a slower corner, and specifically with wind resistance at higher speeds, like we are right here, 100 miles an hour.
Yep. 100 miles an hour, lots of aero. Johnny Nine Lives wings are coming into play at this point. Davin Sturdivant says hello, by the way, Eric.
Yo.
Guys, Not Famous Racing Driver. Check them out. Code APEX Pro at checkout, 10% off all their apparel. Mugs. I need to get a mug. I've got the sweatshirt. I was wearing it yesterday. It's a good material. So what I'm going to do here, now we're looking at that. So Eric's confirmed for us 0.22 positive G means we're still accelerating, right?
Check.
Right here. I'm going to go from the longitudinal G channel down to my RPM channel. And now I can see what RPM I'm pulling. Now this black dot is going to represent RPM. So if I press and hold on the dot, 6250. So just like you thought, Eric, that's probably really close to the red line for this car, right? Which is
move that cursor down a little bit and let's look at his RPMs.
Sure.
To the left. Yeah, down track. Sure.
Down track down here.
See this.
Decelerating. Decelerating still. Ooh, what does that mean? We just saw RPM jump.
Let's ask Marlon. Marlon, what's that mean, bro? Check out the Apex lights down there too. He's getting that grip. There's a lot of green lights there as he brakes and turns and rolls in there. Not braking yet. He's rolling in. And that, am I correct? Wait a minute.
Yes.
We'd have to see that.
Braking.
Yeah.
braking from this point on right here.
Just for fun, could you throw up the speed trace on the bottom there? Show everybody how to do that.
So the point I was getting to right here, where we see this, you see how our Apex score is green, and we got a little orange and yellow right here. That's going to be our downshift represented in the Apex score, but I also saw that represented in RPM. He was downshifting. We know he was approaching in third gear, so this is the downshift to second gear. But something I noticed in the gearing data when I go to gear, this says we're going from third to fourth to second.
Well, that's just a calculation based on RPM.
Right, based on RPM. So it's assuming that we went up to fourth gear here. What might have happened there, based on this little bobble, is there might not have been, he might have not gotten it into second very quickly and held the clutch in for a little too long or something like that. And it, for some reason, thought that we were in fourth gear. Maybe do some.
Well, he's rolling it in super fast. Look at all those green lights through that whole process.
Yep.
He's hoofing it through there.
Absolutely. And guys, feel free to ask questions while we're going through this. I've got the live link pulled up here. So does that make sense on how we set our gearing and change it if we're looking at that in the app? Is there anything that's to be desired in that conversation there, Eric?
We want to start testing things. What's really nice about having that RPM channel is you get data that has that. So, everybody knows where you're going, man, I'm high RPM. Should I pull a gear or not? Shift, or should I hold it in this gear? You already know on the track where you're doing it. OBDII module with RPM validates that. You're like, there you go. There it is right there. You're showing it right there.
Yeah.
So all those areas are potential opportunities where they're higher RPM, right? Because that's when you shift. And they don't have to be at the peak, right? Above 6,000, they can be lower. So anything on this, I would say above 5,000 is an opportunity to investigate.
Yeah.
To try.
Absolutely.
And that way you can confirm. And that's what advanced drivers typically do. But this concept is equally available with the results with newer drivers. New to DE drivers.
Marlon said, could it have been a blip of the throttle when you asked him the question, Eric, about what that could be? And that would be spot on. That's exactly what that is. So that's why I pulled up the RPM graph down here to show this is him approaching, Doug approaching in third gear, decelerating, and that blip right there that we see, this is a graphing of RPM over distance on the track. That's our blip to downshift into second gear. And then we see second gear upshifting a little below red line. Actually, there's no upshift here. I apologize. There might be an upshift somewhere in here. I think this actually might be the top of second. That's where we can go find that out.
Hey, would you kindly go to Marlon found that little rev blip, right? For the calculations where it says 4.0. You go on the front straight into the braking zone there. See if we can see anything else. That's real fast. You'd be downshifting there too, right?
Yep, absolutely. Let's do that. I'll move forward. See if we can get to our downshift. It's going to be right before the start finish. Yep. I can see it right here. This is our blip into the throttle right here. So we're carrying fourth gear, and right here, the driver's going to shift, going to downshift. Let me go to RPM. And we can actually see it in throttle position as well, but we'll go to RPM. The way we're going to tell if we're downshifting is we'll see a sudden spike in RPM when we're not really expecting it. So I apologize. I'm moving the screen around a lot. But what I did right here is right before the start finish gate, RPM is decreasing, 44.19. Let me tap it right here. Oh, 5,050. So somewhere in this space is where the downshift is happening.
Which is normal, especially on a big straightaway.
Yep.
What kind of speeds he hitting terminal right there? Terminal meaning maximum top speed. Look in the lower left, everybody.
So the way I'd like to find that, we can overlay speed on the racetrack, but that's not going to give us the best indication of or the easiest way to find the top speed. The easiest way to do that is going to be to pull up our speed trace down here by going to speed. And then finding the highest peak. So it looks like, Eric, to answer your question, right at a kiss above 140 miles an hour, 141.
Yep. Then do a big old bunch of brakes.
141 and a half right here.
Hey, will you come out of the sinkhole? Let's talk about how everybody would use this, the value of the gear selection. So we're coming out of the sinkhole. It's a left-hander. Depending on your car and gearing and time of day, some people might run out of gear here. So as you leave the top, you might be in a high RPM car and going, man, should I short shift? Or should I drive the car real punchy, real high revvy? From there on to the front straight.
So we're talking about where you want to upshift exiting the
This is an absolute experiment that if some of you are out of gear coming onto the front straight and it's real peaky and it's real revvy, as noted by just touching the throttle, it's really lungy, right? The benefits of pulling the next gear is the chassis is more stable, and that's what's required through there. You don't want a real hyper squirrel on Red Bull kind of feel of a car.
So let's look at absolutely. You don't want, you get a lot of drivetrain tension when you're high in the RPM, right? And when you release off the throttle, weight transfer is a lot more dramatic. So you put a lot more weight on the front.
Which is the same principle of why you typically why you short shift in the rain. You don't want to have those big lungy, jerky accelerator feels when you're off throttle, on and off throttle.
You know, it was interesting. I did a rally driving school quite a while ago, and in rally, I tended to.
I think he's making this up, everybody. I'm pretty sure he's making this up.
Yeah, I'm making it up. I've raced WRC. I don't know what you're talking about. I was upshifting, so I'd get close to the top of the rev range, and I would upshift. But there was a lot more wheel spin, and until you're really, really sensitive to it, you don't really detect it. So the car would wheel spin, and I'd be going pretty fast. I'd be like, oh, this is top of second gear. I'm gonna go up to third. Well, then it would start to bog a little bit in third. And the instructor I had in the right seat is a Welsh guy. He's rallied for years. And he goes, no. Leave it in the lower gear. Leave it in the lower gear. You can't feel anything when the surface moves under you. You want it to keep it in that on that higher gear so that you can use the weight transfer. You have to exaggerate the weight transfer a lot more in loose surface driving. All right. Like that chopping off the throttle, you might not want to brake, but you can chop off the throttle. And if you have it at the higher RPM, that weight's going to go forward. So that was a really interesting lesson that I learned. And a lot of times we're doing the opposite in a really grippy situation. We don't necessarily want that peakiness or that response in the relax of the throttle and the immediate weight transfer that happens with the drivetrain. So Eric, let's look at Doug's data. I've got the gear selection channel overlaid on the track. So yellow is third gear, green is fourth gear. And we've got our RPM channel on the bottom graph here where we can usually display the speed trace. This is where he's upshifting. Right here is where we're upshifting at 6,200 RPM. Do you think that he should be shifting sooner, or does that look good to you?
Well, in all honesty, for me, this is kind of advanced. I'm taking my car to the dyno and I'm going through the gears and I'm figuring out where the power's at. Most people go to measure the top, how much did it make, the peak number? I want to know what second, third, fourth, fifth, and sometimes sixth, depending on your car. I want to know what the curve looks like for each one of those so I can drive in that RPM range.
Absolutely. And what's interesting too is that he's already well onto the front straightaway with his hands straight before he has to upshift, before he reaches the top of the RPM range. Mm-hmm. Right. So he's easily at third gear. So let's say at this corner right here, let's see what RPM.
Is that a trick pony motor he's got in there?
No, I think it's a stock motor.
Okay.
A relatively stock motor. So he's at 5,000 RPM right here at the apex of this corner. So what that tells me is that third gear is probably perfect for this whole section in this car.
Mm-hmm.
I would think.
Mm-hmm.
He's at 4,300 right here. So that is going to give you some dramatic weight transfer if you chop off the throttle at 4,300, but not as much as 5,500 or 6,000, right? So I don't think he's going to benefit. And really the question we're asking here is do we upshift in this space right here from third to fourth, or do we drag it out onto the front straightaway? I think that's what most people, if you're driving NCM or a track with a similar combination of corners right here, do I upshift early to settle the chassis and maybe I can get on the throttle sooner? Or do I drag it out in a gear?
Why did you pick those two areas for your choices?
These two areas? Because we're not shifting mid corner, right? Ideally.
Why?
Well, what happens when you engage the clutch?
I believe you, and it's the correct answer. Yeah. What's the car doing, everybody?
Yeah.
It's in roll right there, and it's going like the Dickens, right? You can see right now with the cursor in the lower left with a speedometer, the thing's going 102 miles an hour right there.
Yep.
That's hoofing. He doesn't want to disrupt that chassis.
That's right.
See the blue dot? Yep. It's 86 mid corner. He doesn't have, he can't, what kind of lat G you think there?
We'll see.
One
lateral G.
One. I'm guessing how to do. Aha. Pretty close.
Yep.
So that's so you're dancing on the edge. You don't want to be disruptive fore and aft, which is what think about that. What a shift would do. And it shakes the car side to side as well.
Right. And we can also, because we have OBD2 here, we can look at throttle position. So I'm going to leave lateral G displayed on the top screen. I'm going to go to TPS on the bottom screen. This is
again available via OBD with
OBD2
with the device. That sounds like a sales pitch, but quite frankly, this is what you're using it for. That's
right. I'm going to slide the slider to the same place that I have selected right here. And I'm using this slider down here to move the dot. I'm going to put him, whoopsies. I'm going to put him right on top of this 1.0 if I can get it there. There we go. That's close. Okay. And then I'm going to look at my throttle position, which is down here. Right here. 49.02. So we're at partial throttle here. This flat top right here.
49% throttle. So sort of has it halfway pushed down. Fair statement-ish.
Max in this car. So this is what's important to know about TPS is it's a measurement of the butterfly valve on the throttle. So it's not going to be absolute. It's not going to be 0 and 100 because the car has to idle. So the butterfly valve is going to be open at idle. Also, the butterfly valve usually is, for whatever reason, this is in every car, your maximum throttle input is going to be somewhere around 85% or TPS, 85 TPS. I don't know. Yeah, Ravi Tomerlin says, nice shirt. We Don't Lift Racing hooked us up with some rad old school Apex Pro shirts. Appreciate it, guys. They're available on the website if you need them. Or there's a couple of them, sorry, just the logo shirts, not these guys. So right now, Doug's at 49% throttle, little over half throttle. So let's talk about why we don't want to engage the clutch at that point, right, Eric? He's got, what's the car doing? Where's the weight in the car? He's turning to the right and he's on the gas pedal.
100%. Yeah. You want to go to the
left tire, right?
You want to go on the bottom. This is to confirm everyone. You want to go on the bottom selector and go to latitude.
You want me to go to?
Yep.
Lat G.
Yes, everybody. See how they're doing that? We're going to confirm right there. And I want to know that value, what it looks like.
Yep.
There you go. Look at that peak. That sucker's laid over, which it should be at Apex.
Yep. So this all looks really good. So long story short, why we are either going to upshift from third to fourth in this area or wait until we're here is because we've got one lateral G in the car, a lot of G. And we're also at 49% throttle input. So the weight's solidly on that left rear tire, turning to the right.
Yeah, you're not floored, so you're not redlining, right?
Right. What happens if you slam the clutch in right here? Where does the weight go?
You hit that wall, probably.
Yeah. No matter what you do with your foot on the throttle, the weight's going to go straight to the front, right?
I want to show everybody this. In the upper left, you can see that the heat map for the track, it says position colored by lat G. Everybody see that? Right. And right below that is mile per hour for the blue dot. Easy to see. But more importantly, look in the lower right. Look at those green lights, gang. That dude's getting everything out of that car at apex, half throttle, 1G, getting ready to rip it.
Yep.
Getting ready to just put power down. And if you go back kindly to the lower selector for TPS. So he's sliding that down. Look what he's getting ready to do with his foot. You want to put your, show him what he's getting ready to do there, brother?
That's right.
He's getting ready to go hammer down, and it's not a trickle. He's going mash. He's going mash. Everybody see that? That's a validation. You'd be able to see that also in longitudinal. You want to go there as well on the bottom selector, that same spot. What does mashing the gas at 1 lat G and 83 miles an hour look like? Right? That's what we're doing right there. Where's the zero line, brother?
Right here. I'll actually do, I'll do this for you.
So if you do not have a throttle position, if you don't have this device and you can't pick up throttle, the next best thing, you got sports fans, and you need to read this. You need to be able to read this. If you are good at data, you're looking at other people's data and you're making recommendations. And in this case right there, where that 0.29 is, right? That's 0.29 positive longitudinal G's, which means accelerating. And that's a big handful of accelerating at 83 miles an hour. If that was probably see 0.1, Andrew, 0.8, 0.85 point, guys, excuse me, 0.085, not 0.3, 0.085. So less than. So we know that this is a big car ready to throw down, and it's throwing you back. And that's what that feels like, that 0.29.
Yep. Yeah, that's, I'll pinch it a little bit wider here so we can see when he goes to throttle, just like you're saying, we're going to see this. This is where we are right now. This is 40% throttle. When he goes to wide open at the apex.
Yep.
40% throttle, we see this increase in longitudinal G up to over 0.4, right?
Which is big power at 80 miles an hour.
Yep. That's not something you would see in a Miata at 80 miles an hour.
For you instructors, you need to know, you would be able to tell and need to see this if you're an instructor or somebody wants to help somebody with data. Anything acceleration rate, which means the slope, and the value, which is, like you said, going up to 0.4, that's a big car. You need to be able to see that in the early data and go, yep, I know what that is. Yep. If you didn't know, there's your answer. And if you said Miata, Miata's not the answer in this case. It's not, because it would be a lot less, less of acceleration.
Yeah, absolutely. So as an instructor, you can go to the longitudinal G channel and see these spikes over 0.4 positive G and immediately know that this thing's got some power.
Especially at 80 miles an hour. If it was second gear coming out, it might throw you back quite a bit, but that's a slower corner where a car accelerates harder.
Yep, absolutely.
But not at 80 miles an hour.
Not at 80 miles per hour. So I think this was a really good explanation of how gearing comes into play. So what's also interesting, Eric, is if he was in fourth gear here and he went to full throttle, that might look a little differently, right? Longitudinal G.
And he probably tested, in all honesty. Hoofing a car through like this, he probably tried.
Yeah.
And knew in his data.
I like that you brought up the apex lights too, because at this point on the track, what we're trying to confirm is, could he be at full throttle? Right? That's the question you have to ask if we're looking at the data at this point, right? Could he be at full throttle right here? And I would venture to say that if we go back down here to our throttle position channel, and we see that he's at 49% throttle right here, right? This is where we are on the throttle. And we're at wide open, almost all green lights. I would venture to say probably not. He's probably pretty darn close on throttle input, right? That's a confirmation that this driver's close to the limit at this point. So squeezing more throttle or having more throttle applied at this point on the track is probably a lot to ask.
If that last green one was red, tell everybody what that means. Same scenario, one red light, one
Same exact scenario, one red light.
Uh-huh.
There's probably 10, 20% more throttle left. That means that the point that you're plotting on the friction circle is not at the absolute edge.
And again, we're looking at the last green light, the 11th light, which is a green light. If that was red.
Eric, real quick, we'll wrap it up because we've been on here quite a while at this point. Thanks everybody for watching. I posted a link to APEX Pro t-shirts if you guys want one. There are a couple left. And then also don't forget 10% off Not Famous Racing Driver apparel, code APEX Pro. All the important stuff. And then I'll also drop a link to the OBDII interface in here so you guys can do this for yourselves. And feel free to reach out to us. We'll help you as much as we can with this information. The last thing I want to ask Eric is, at this point on the track, with what we know about the lateral and the longitudinal load of the car, where is this going to be plotting on the friction circle?
Ooh, that's good. Well, we know that we're throwing a lot of green lights, right?
Right.
We know that we're getting ready to accelerate, right? We know which we know we're not braking. Think about where the braking is, and we know we've got a lot of lateral load. We're almost going from slow acceleration to maximum acceleration, and maximum acceleration would throw the friction circle indicator to the top, right? Because the car's accelerating. Does everybody understand that?
Yep.
Kind of what is it not? And we know it's got 1 G, lateral G. So it's probably somewhere near the vertical axis, near 0, and possibly a little bit behind it. And on the side by 1 G.
Would it be right here?
Yes, sir. Looky there.
Excellent.
I tried to break that down for everybody. Once you start seeing this, look at that. That's a really pretty shape. Look at the absence in that inside of his friction circle of data points. So inside that is desired. That is what we want to look like. Look at that braking at negative 1.2 and how it goes almost directly to the outside. It almost looks like a diamond. Does everybody see that? A diamond, like a diamond ring.
Yeah. Excellent. Eric, you nailed it. And that's exactly what I was asking is which quadrant is this plotting? Is this corner right here plotting points in? I think that's something really important. Which quadrant is this corner plotting points in? That's an important thing to think about. And if we're turning to the right and accelerating, it's going to be the top right quadrant, right?
Say that again. Say that again.
If we're turning to the right and accelerating, right hand steering input, right pedal, top right hand quadrant of the friction circle.
Pretty simple. Turning right is up in the upper right.
And because this is NCM, and most road courses tend to have a more concentration of plotting on the right hand side of the friction circle because we're turning right usually once more than we're turning left.
Clockwise track, like Mid-Ohio. Yep.
There's 2 corners in particular at this racetrack where we are accelerating and turning right for a very long period of time, which is why we have such a heavy concentration of dots in this quadrant of the friction circle.
If you're listening, give us a shout that you're learning something new. That's the goal. That's the goal, guys. When you become more powerful with data, you pass that information along, especially if you're an instructor, and it makes for better drivers and safer drivers. It accelerates everybody's learning curve, saves you a lot of tire and brake cost because you're not driving the car improperly, which is typically over braking, brake pads, tires, right? And fuel, because you're really mashing the throttle from a low speed. It's an automatic dollar savings, hands down.
Absolutely. Kevin Ramin says, wow, I love this stuff. Great job. Marlon says, best way to spend lunch with the Glitter Twins.
Glitter Twins.
And Ryan Burkert says, great info. FYI, the dual presenters and screen is all working great.
Thanks,
Look at that. Our hard work's paying off.
Boom.
Cool. Eric, thank you for joining me. This was awesome.
Anytime, brother. Anytime.
Absolutely. Guys, let us know how valuable this was. Hit us up with any questions.
Put
And,
everybody put a little comment. What'd you learn? Make a sentence on there. What's one thing new you learned? It benefits other people by going, huh? I'd be interested to know. And if there's anything that you wanted to learn, throw that in there as well. We're looking for content and ideas to do this more frequently, record them, make a little brief library of this information.
Excellent. Let us know what you learned. You guys have a great week. Happy issue. Hold on one second. We got a question. One issue I had with the person I was helping, he was colorblind and couldn't see the difference between red and green. Well, there's a couple of options for that. And Spire Motorsports was the question asker. What I would recommend anytime in your data that you're looking at the color differences, this last guy on the friction circle page is going to represent the color. All right. And you can change that to blue and red. So all the dots are blue, all the dots are red. For the friction circle, the color is not important. So this is a great thing to use if you have someone that's colorblind. A lot of red and green is going to be used on the screen right here. Something else you can do is change the display of the unit to blue and red. A lot of times men's color blindness is very commonly red and green colorblind, red, green colorblind. That is fairly common for men. So I would recommend going to red, blue, and they might not know what color the red is, but they'll know what color the blue is, and they'll be able to distinguish between the two colors.
Can you go back to blue?
Answer your
Can you
question.
go back to blue for a second, sir? Guys, if you're out in the sunlight, this choosing blue here gives you a bigger contrast when you're looking on your device, right? It's easier to see than if it was a lighter color.
I'd recommend using blue when you're looking at this, with direct sunlight on the device's screen. If you can get in the shade or stay in your car to review your data, or go somewhere inside where you can get some water, drink some water, review your data, then talk to your buddies about it. That's ideal. All right, Eric, have a great Thanksgiving. Have fun with your sister and her family and all that sort of stuff.
Thanks, everybody. Look forward to reading your comments. Happy Thanksgiving.
Happy Turkey Day, guys. Let me figure out how to end this thing. It never ceases to amaze how. Aha, I got it. All right. See you later.